for this quiz. Okay, solution. So two of them wanted to look at the solution, and one of them, what he did was, he know that he got the wrong answer because I written the paper, right? And what he did was, he asked me, he redo the question and asked me if he get the answer correct. Okay, so I told him, yes, you got the answer correct, because I think he knows what he did wrong in the quiz. So this is how he learned. He looked at his question paper, the graded paper, and he knows that he got maybe question 2 wrong. Question 2 wrong. So what he did was he redo, and he said, is my answer correct? Okay, he telegrammed me and asked me about the answer. I said, yes, correct. But the other two students wanted to see my solution. I believe if you look at my solution, without understanding the solution, and by memorizing the steps that I've taken to solve the problem, I don't think it's a good way to learn. The best way to learn in this case is to redo the quiz and check if the answer is correct. How do you check? You can ask me for the solution or the answer. So that's one way. So it is up to you. It's up to you to make sure you understand. Again, in this class, I think in university level classes, you need to understand. If you can do it without understanding, then it is a problem. Normally, what I'll stress to my student is that you must understand. Okay, when you understand things or you understand the subject matter, it is easy for you to solve the problem. Or you can easily know what the steps are. Okay, I had one question from my master student yesterday asking me about his solution. He basically just copied my steps from my solution. This is why I don't like to give solutions, especially when printed solution. So what he did is just copied the step, but he didn't understand it. So I asked him yesterday, do you understand what you are doing? I just follow your steps, sir. I think this is wrong. This is a wrong way of studying. Okay, so please make sure you understand what you are doing. Okay, please understand what you are doing. All right, so please, I'm giving you today, what I'm trying to tell you now is how I solve the problem. Please make sure you understand. Okay, please make sure you understand the solution here. Okay, right, so the first problem here, what is the precision of the measurement tool shown above? Anyone? Before that, let's ask a question about what is accuracy and what is precision. So what are the differences between accuracy and precision? Anyone? Did you read the slide? Anyone? No one. It's in the textbook, and it's also I also gave you the slide for this topic, accuracy and precision. So what is accuracy and what is precision? Anyone? Did you do your pre-lecture activities? Did you do your post-lecture activities? Did you watch my video? This is not good, not a good sign. Okay, yes.
From what I understand, accuracy is like the value which like close, if it's a measurement, then it close to the measurement. And for the precision, as for measurements, it's close to each other, like it's at almost the same spot for precision. And for accuracy, the value is more close to the accurate value, that the supposed
true value. You mean the true value?
Yeah.
Okay, so now, okay, so I think Nur Izzah has the idea. Let's give an example. Okay, let's give an example. For example, let's say I have something that weighs maybe 50 kilogram. Okay, so 50 kilograms. So I have two machines, two weighting machine. So this is, let's say, machine A. Okay, this is machine B. So when I'm using machine A, I know the true value of my weight or whatever things that I'm going to weigh is 50 kilogram. But when I use machine A, weighing machine A, what I get is maybe 49.5, 50.3, 49.7, and maybe I get 50.1. Okay, and the other one, what I get is 50.1, 49.9, 40, 50 point, oh, not 40, 50.2, 49 point, sorry, 50.1. So now, my question is, what is the characteristic of these two machines, weighing machine? Which one is more accurate, A or B?
B.
Okay, B. How about which one is more precise? Which one has more precision, A or B?
B.
B, right? In this case, B. Because the first thing you must look, it is closer to the true value. So this is what it meant by accurate. And then when we keep measuring, when we repeat the measurement, the deviation from the true value is very small. This one is 0.1. This one is also 0.1. This is 0.2. This is 0.1, right? So this machine here is not only accurate, but also precise. How about this one? See, this is not as accurate and it is not as precise because the difference here is 0.5, 0.3, 0.3, 0.1. This has a lot more deviation than this one, than machine B. So in this case, B is accurate because the value that we get is very close to the true value. And it is also precise because the deviation from the true value is, on average, very small. Okay, very small. So this is the idea being and accurate. You might get a machine, for example, let's say I have a machine C. Okay, my measurement is 48.1, 48.2, 49.1, and then 40, 50, sorry, not 40, okay, sorry, this is wrong. 48, 48.0, and then 48.1. So what is this machine here? What is the characteristic of this machine here? Is it accurate?
No.
No.
No. Is it precise?
Yes.
Yes.
It is precise but not accurate. So how do we make sure that our machine is accurate? What do we do? Calculation. This way. This is why all the weighing machine at the shop, they have to have these calibration stickers, kan? It has been calibrated by a certain department, okay? Because they do not want you got cheated. So you pay for 50 kilo, okay? In this case, the seller might lose some money because it is showing less than it should. For example, you want to buy 50 kilogram of durian, okay? It only show 48. So the seller will lose some money. Okay, so this is the idea behind accurate and precision. So I think in the slide, it shows something like this. Where is it? This one. So what we want is this, right? We want our numerical methods to give us an accurate result. In this case, the accurate result means it is very close to the true value of the solution, right? And also, we want to have lesser error, because in this case, it is not only accurate, but it is also precise. Mean when we repeat the calculation or we repeat the measurement, the error, the deviation is very small. Okay, what we do not want is this. It is not only not accurate, but also it is not precise, right? This is okay, but what happened here? What happened here? This is due to, let's say if you are talking about measurement equipment or measurement tool, this equipment is not calibrated. So it is not accurate, but precise. How about this one? Anyone?
This is accurate but not precise.
Yeah, this is just like when you measuring something. Let's say I have something here that I know the true value is 10.5. Okay, now what I want to do is, let's say this is 10.5 mm. So I'm using a ruler to measure this. So my ruler say, okay, so this is my normal ruler. I don't have an example here. So we know that the ruler has this graduation of every 1 mm, for example. So this is 10, this is 11, this is 12, right? So, and the other machine, the other measurement equipment is I'm using caliper. I'm using caliper. So, which one do you think is the best equipment for the job? Can my ruler give me a good reading?
No, the be better.
Okay. So, what is the accuracy of using a ruler?
This ruler
Uh-huh.
not very accurate.
Yeah, but I'm asking you, what is the accuracy?
1 millimeter.
1 millimeter, because the graduation here every 1 mm. So it is accurate to up to 1 mm. How about this one here, caliper? This is the same one as this one. So what about caliper here? So it is accurate 0.1. 0.1. So
Yes.
in this case, okay, this is 0.1 mm accuracy. So if I know my measurement, the thing that I want to measure is up to 1 decimal place in millimeter or 0.1 millimeter. So the best thing to use is to use a caliper, because it will give you an accurate result, right? But in this case, and I'm using a ruler to measure my object of 10.5 millimeter, what kind of precision do I get? What is this? I know it is 10.5, but I think if you look at this, maybe from your point of view, you say, this is about 10.4. Oh, no, sir, this is 10.3, right? And then somebody else say, no, this is 10.6. Why? What's the problem here? Because we have an error here, right? Because our equipment is not it's not designed to measure up to 0.1 mm. It is only accurate to up to 1 mm only, right? So in this case, we might have 10. I don't know, maybe this is 10.4 and plus minus 0.5. So if my object true value is 10.5, then I know my measurement is between something is not right here. With 10.9. Okay, so this means that my measurement can be anywhere from 9.9 to 10.9, right? Is that correct? 10.4 plus 0.5, it becomes 10.9. Let me delete this. So now, which means this is anywhere between 9.9 to 10.9. Am I correct? Because this is the precision of my ruler. And you see, does this range contain the true value? What is the true value? 10.5. So now, for this case, okay, the precision of my ruler is always half of the smallest value it can measure. In this case, 1 mm. So the precision is plus minus 0.5. So the answer for this is, for this part A, what is the smallest value it can measure for your caliper? For your caliper, what's the smallest value you can measure? This value, right? So what's the precision then? What's the precision? Anyone? Okay, so the precision is half of the smallest value, which is 0.05 mm. All right, so question number 2. Okay, before we go to question number 2, I want you to answer this question. Okay, let's see, let's share this. Okay, can you see the photo there? Which one is the correct answer, A or B? Anyone?
A.
A, are you sure?
Yes.
Or is it B?
Doctor.
My son is learning algebra, right? So I showed him this picture and I asked him which one is correct. So he was confused. So both are using Casio calculator. A is also Casio, B is also Casio, and they type in the same numbers, but the results are not the same. So 1 and 9. So what is the correct answer? Okay. So
A.
is it A or is it B? So how many of you? How many of you say A? Can you raise your hand? I want to see. Use the. Okay. Wow. Okay. I guess everyone is saying A. So I hope you know why A is correct. Because if you use Casio calculator, this one, 570 ms, which is the one that normally our student use, you get, hopefully you get one. So the problem here, what is the issue here? What's the issue here? So how do we check which one is the correct answer? So note that any number, so I think it was 6 divided by 2, 2 plus 1, right? Is that the one? Sorry, 1 plus 2. 1 plus 2. So I told my son that when you type in your calculator, make sure this is 6 divided by 2 times 1 plus 2. And then because divide and division and multiplication are of the same order or of the same priorities, then we have to go from left to right, right? So this is 6 minus 2 times 3. So, okay. Okay, so now, what is the answer? I get 6 divided by 2 is 3 times 3 equal to 9. Wow. So which one is correct now? Which one is correct? Can anybody tell me? Is it 9 or is it 1?
It's B.
Are you sure? I think so many of you said A just now.
Yeah,
Which is one?
I thought it was A because I was
See, you got tricked. Okay, so the issue here is that when you type in your calculator, make sure this is the very basic thing. Make sure there's a plus, there's a times here. Okay, when you use your calculator, for example, if you use your Android phone calculator without the multiplication sign, you can get the same value. Okay, so be very careful when you're using your calculator. Be very careful. I have my calculator here somewhere. Where is my calculator? Okay. Okay, let's wait. Okay, so now, did I convince you that B is correct? Can anybody test your Android phone calculator or your iPhone calculator, see if you get the same answer as 9?
Got 9.
So, now are you convinced? Okay, so it's 9, it's not 1. So be very careful, be very careful. Be very careful when you're using calculator. Always use that multiplication. So let me show you my calculator here. Okay, this is my calculator. I have the physical calculator, which is Texas Instrument. So let's do this again. 6 divided by 3 bracket 1 plus 2, right? And this should equal to, oh, sorry, I missed something here. What's this? What's the value? 6 times
6
2.
divided by 2.
6 divided by 2. Okay, 6 divided by 2. So let's redo. 6 divided by 2. Oops. 6 divided by 2. Bracket 1 plus 2. Oh, 1 plus 2 should equal to 9. See, note that in my calculator, automatically it put a dot there, which means that it should be a multiplication. It should be a multiplication. Okay, so why am I the it thing? Uh, there's a bracket there. What's wrong with my audio? Any
You
audio is okay. So okay.
On your connection.
Is it okay now? Because I'm using UTM's connection. I'm not at home. At the office.
Okay, I try now.
Good. So, so this
Problem again. It's
something. Let me know. Uh, now, but
you still on the problem, Doctor. Your voice still cracking. I think.
uh, uh, is it okay now? Uh, okay. So sekarang
That's good.
I'm not you. Your voice screen. So the connect from good, yeah. So uh, uh so do this on call, yeah. The Rick Master. Yeah. So number two, yeah. Crossing. Crossing. But So
Sorry, did you say
uh, two, hmm,
your good?
here for this problem here.
Sorry,
This
Doctor,
one.
the slide is not open yet.
The slide is not open. This one. You should see it, right? I share it. Can you see the slide? Anyone?
Yes, doctor, we can see it.
Yes, Doctor.
Okay, so basically this is question number 2 is on this. Is on this figures, sorry, this slide, page 7 to 11. To 11. So it even has some one example here. Okay, one example. So this is page 11, which is an example. So this is the same thing as your quiz, So let us do this one. So if you look at this one, so what I did here is let this equal to y. Y is 13.56 over 157. So what is the number, what is the significant figures for this problem here? So this is basically your division, right? So for division, what you have to look is, in this case, this is 0.086, 369, 426. Okay, are all these numbers here meaningful? Okay, no, not all of them are meaningful. So the question here is, so how many significant figures here is meaningful? So how do we determine that? This is what the rules are saying. Okay, this is what the rules are saying. All this, yeah. Sorry, yes, this one, all this. This is rounding. Okay, this is addition or subtraction. This is multiplication or division. It says that smallest number of significant digits is used. So in this case, so the smallest significant digit is here, 3, right? So this is equal to 0.086. What, 3 or is it 4? So to determine the last number here, you need to look at the rounding rule. So in this case, it is 4. So this is 3 significant figures for y. And look at this one as our z, which is, if we do it correctly, this is 5.5, 005 times 10 to the minus 5. But again, taking a look at this, what is the least significant number, number of significant figures? This is 2, this is 4. So this is equal to 5.5 times 10 to the minus 5. This is the correct answer. So this is only 2 significant figures because of this one. And y is 3 significant figures because of this one. 3 significant figures. Now, the next thing is, let's say x equal to y plus z. And our y is this one, 0.0864. And our z is 5.5 times 10 to the minus 5. So how do we do this? How many numbers should we retain? So for addition, what we need to look at is this one. Okay, this one. So you need to look at the most significant return is the rounding of the final result is done in such that the position of the last written digit is the same as that of the most significant last written digit. Okay, so in this case, this is only in this case, this is only one decimal place. So the answer is one decimal place. In this case, it has, okay, note that it has the same exponent. So in this case, this is one decimal place. The minimum is one decimal place. So this answer is one decimal place. So let's look at our question here. So we need to make sure this is 0.0864, or let me rewrite this in terms of exponent. This is 8.64 times 10 to the minus 2 plus 0.0055 times to the minus 2. So note, in this case, it becomes 8.645 times 10 to the minus 2, right? So what is the final answer? So note that the least decimal place in this case is only 2 decimal places, right? This has 1, 2, 3, 4 decimal places. So we need to get this 8.64 times 10 to the minus 2. So this is the final answer. So the question here is, look at this. This is 5. Why is it not 8.65 times 10 to the minus 2? Okay, so this is documented here. Look at this thing here. This is even, this is 5, so we retain even number. This is odd, and this is 5, so we increase by 1. We increase by 1. So that is the answer for question number 2. Okay, now let's look at question number 3. I'm sorry, I have to rush because I plan to give you until the third question, because your quiz, okay, your assignment next week, I'm going to give this afterwards, is based on this. So now let's look at this. We know that this equation, it has 40 equal to 9.8 times 68.1 over C. Oh, okay, let me use this. Okay, so this is 40 equal to GM over C, 1 minus E minus C over MT. So the values are given. So in this case, for my set of question, this is given. G is 9.8, M is 68.1, C is not given. 1 minus E minus C over 68.1, and T is given as 10. So 10C. Okay. So find C. How do we do this? Anybody get the correct answer for this question? Some of you did a magical thing, without anything. Say you got C equal to something, or M equal to something, which really surprises me, lah. There's no work, and suddenly you get the answer. Maybe, I don't know, maybe your calculator can do that. But again, it is not about getting the answer. It's about understanding how to get the answer. Okay, there's a difference, getting the answer and understanding how to get the answer. So in this class, we need to understand how we get the answer. So that's why if you get the answer correct, I will, without any work, I will say show your work in your paper. So how do we do this? What's the problem here? Can anybody tell me what's the issue here? What's the issue? Anyone? What's the issue? What's the issue? Senyap ni, putus ke? Am I disconnected? Somebody say something, please. Oh, okay. So that's exponent here. So C is in two places, right? It's not easy. So one is here in the denominator, and not only it is in exponent, it is also here. Wow. This is not easy to solve. This is not easy to solve. Okay, algebraically, it's not easy to solve. Okay, using your normal algebra method, it's not easy to solve. Okay, so how do we solve this then? So this is where we use numerical methods. Okay, this is where we use numerical method. Okay, by the way, time has ended. Do you have a class after this? Do you have a class at 11? Sorry, at 12? Okay,
Yes,
so anyone do not have class? If you do not have class, you are welcome to stay. If you have class, please go, because this thing is recorded. I'll be giving you the recording later on. Okay, so if you have class, please go to your class. If you don't, please stay. Okay, please stay. For those who are having class after this, please go to your class. This session is recorded, and you can see the recording afterward. Okay, so the idea here is that we cannot solve C easily. Okay, if in this case, for example, in this case, if for V, if everything is given, G is given, M is given, C is given, we can solve it easily. So in this case, in this kind of equation, where we can put the variable on the left-hand side, okay? So if we can put the variable on left-hand side alone by itself, then we call the variable as a we call as an explicit variable. So V is what we call not only dependent variable, but also in this case, because we can put V on the left-hand side on its own, is what we call an explicit variable. Explicit. Contrary to C, can we put C alone on the left-hand side? How many students do I have left here? Oh, still a lot, still 31 students. Can we put it on the left-hand side? Can we put C on the left-hand side? Can we put M on the left-hand side? Can we put T on the left-hand side? Okay, we know that we cannot put C on the left-hand side because you tried, right? I think you tried in your quiz and you were not able to do it. Okay, you were not able to do it. So in the case if we cannot put the variable on the left-hand side on its own, this is what we call implicit. Okay, implicit variable. Okay, is a variable that cannot be put on the left hand side on its own, by its own. Okay, so how do we solve this? How do we solve this? How do we solve for C? How do we solve for C then? So, since we cannot do it analytically or algebraically, so what we need to do is to solve it numerically. So somebody mentioned about doing differentiation. What are you going to differentiate? Okay, you differentiate what value against what value? Zuhair. Okay, turn on your mic.
Yes.
Differentiate what with what? With respect to what?
I plan to differentiate the both side to become d over dt. But I tried doing an quiz, but it doesn't work. So
Yes, it will not work because you do not know what is dvdt. What's the value of dvdt? Right?
I do not know. Yep, true.
Yes, dvdt is not given. The value of dvdt is not given here. So this is the issue. So I think everyone was trying their best to solve this during the quiz, right? And I know some of you just use your calculator, just like my calculator. If you give this to my calculator, it can easily solve the value for C. But the problem with calculator is that it will not tell you how to get the value of C. But in this class, we need to know how we can get C, right? So now let's look at the equation again. Okay, let's look at the equation again. Let's look at the equation again, which is this one here. Okay, which is this one. Okay, so 40 equal to 9.8, 68.1 divided by C, 1 minus E minus 10C over 68.1. So look, we can solve this one way by what? What does equal means here? What does equal mean? Can anybody tell me what does equal mean? This is basically saying that your left hand side must equal to your right hand side, right? So means that this is 40. You can find C by using trial and error, right? So let's try C with a guess value. For example here, okay, let me share you my Excel here. So for easy calculation, let's see how many left here. Okay, 29, 28, which is good, still good. Okay, let's share my Excel slide here. Okay. Oh, where is my Excel? Okay, can you see my Excel now? Can you see my Excel? So now, what I'll do is that I will guess any value of C that will get my left-hand side equal to 40. Now, if I do this, let's say this is already the formula, the formula, which is this value here. Let me try that with, let's say 5. If my C is 5, I get 69. This is not okay, right? If I try with 10, I get 51. This is close to 40 now. So let's try with 15. Now this is 39. So I know, at least I know now, my C value is close to, is about 15 something, right? Because when I do it as 16, then I get less than 40. So I know my C value is between 15 and 16. Oh, sorry, 15 is 39. And let's say 14. 14 is 41. So my C value, by trial and error, I know now that C is between 14 and 15. So this is one way of doing things. Or what I can do here is see that, or what I can do here is I can rearrange my equation here in such a way that 40 minus 9.868.1 equal to C. Okay, 68.1. Then this must equal to what value? Must equal to 0, right? Because we know that from this equation, the left and the right hand side must have the same value. So if this is 40, this whole thing also must be 40, then the result must be equal to 0. So let's do this. Let's do this using a plot here. So I know that if I'm using 15 just now, I get 39. Now let's copy this. And if I use 14, I know it is 41. So my solution is between 14 and 15, right? So what if I do this? What if I change this value here equal to 40 minus, okay? 40 minus, okay? So let's try this again. Let's try with, I know my answer is between 14 and 15. So let's say this is 14.1, okay, until 15. Okay, now let's copy this formula. So where is the answer here? Can you see the answer? Note that it should be, if we plot this, let's plot this and see what is the result here. Okay, let me insert my chart here. Let's do a line. Okay, so what do you think is the answer here? It is between 14.7 and 14.8, right? Am I correct? This is the value. So let's change this to maybe 14.71. And then this is 14.72. And then let's do this. So Now can you see the solution? Can you see what is the value that will make this equation become 0? So it is somewhere here, right? So the solution is somewhere here and here. So this is very, very close to 0. So when C is equal to 14.79, okay, this thing will become 0.01909. So can you say that this is the solution? When C is 14.78, this becomes 0.004. So now the question is, which one is a more accurate answer? Is it 14.49 or is it C 14.78? Why? Nurin, why is 14.78 is more accurate value, more accurate result than 14.79? Yes, it is much closer to 0, right? It is much closer to 0. So this is why we had this accuracy and precision problem in the quiz. So now can we solve this? Can we solve the for C value? I don't know what you get for your quiz, but you can also, I think one of the other question is try to find M, because if you look at this thing here, this equation, M appears here and M also appears at this location. So again, this is M is an implicit variable, and it's not easy to solve it using algebra. So this is one of the methods that we call one of the numerical method. One of the numerical method. So we started with just a trial and error. We try with different values to see, and then we see that we keep testing it until we get these two values, which is the possible answer. So in this case, 14.78 is the more accurate answer because this is very close to the solution. So how about the precision here? What about the error here? The precision or error here? Okay, so that's one thing. Let's say now we change it to 14.781. This is 14.782. Okay. Let's do this. So, which one is more accurate now? Let's say 7.8 just now. 1, 2, 3 zeros here. 7.81. 1, 2. 1, 2. Okay, so this is not an accurate answer. So maybe we can try 13.77. 1. Uh, 7, 8. Okay, let's try 7, 8 lah. So there's no answer here, right? Because it is not becoming 0, right? Not becoming 0. Okay. Okay. Oh, I got it wrong. This should be 7, 8. Okay, there's no solution here. There's no solution because it is not equal to 0 here. So 781 is not a solution here. Okay, so let's try this 7, 7, 7, 7. What was the answer just now? 7, 9, 7, 8. Why am my solution is not correct? Sekejap ya. 781. Okay, the answer is between 780 and 781. This is 80, 80. This is 81. So the answer is here. It's equal to 0 exactly at this location here. So you can again try until you get the solution. So maybe this is 0, 0. This is 0, 2. Okay, so I think I'm going to stop here, but I hope you get the idea here. I hope you get the idea. So we know just now that the solution is between 14.78 and 14.79. So because just now, 79, we get, because there's a 0 here. There's a 0 between a minus and a positive. So this is the possible area that we have the solution. Okay. All right, so I think I'm going to stop here. Maybe I redo this video for the rest of you, for the rest of you who missed the class. Okay, so until next time, until next time. There's no class on Sunday, so before I go, have a nice weekend, everyone. Dan selamat berpuasa, Dan selamat berpuasa. All right, thank you, everyone. So see you guys later.
Thank you, Doctor.
Right, thank you, Doctor.
Thank you, Doctor.